Good morning, AP Chemistry nerds. I hope you guys are enjoying your snow day. What I've got for you right now is your NTI assignment for everybody. I posted a video earlier this morning called Unit 7. KMT stands for Kinetic Molecular Theory and Phase Diagrams. It's about 25 minutes long. The key things for you guys to get are what happens to a Boltzmann's distribution. So you'll see some graphs that look sort of like this. When you change the temperature or when you change the molar mass. So be sure that you look at that. There's two things that always happen to the graph. The peak of the graph moves up and the distribution gets narrower, peak of the graph moves down and the distribution gets narrower, or the peak of the graph moves up and the distribution gets broader. So know which is which. Also, the other key thing is the phase diagrams. So know the parts of a phase diagram. So like know what's on each axis and what states of matter you have at each point. Know the most dense state of matter, and also know how the phase diagram is different in the case of water. So this is what everybody needs to do. Like I said, about 25 minutes long. So be prepared to answer these questions when you show up. Phase diagrams are kind of gen chem, so I'm not going to take any more time to talk about them. Just the video covers everything that you need to know. End of story. When we get back, we'll be doing a dry ice kind of activity. Lab is probably not the best word for it, but yeah, so you'll need your knowledge of phase diagrams to do well in that activity. Also, for the people either in third block who didn't get to the lab, or for everybody in second block who I didn't see yesterday, tune in to the next slide just to try and make your lab go as smooth as possible, especially second block since you guys are kind of running a day behind. Okay, so when we did that problem set, I already did an example that looks like this. This is where we had the tube and you had a volume on the tube that you could not exceed 50 milliliters. This is basically the exact same setup that we're going to have in the lab when you guys come back. So it'll be run a lot smoother if you know what you're going to do with your calculations ahead of time. That way I can give you whatever our environmentals are for the day, you know, the pressure on that day and the temperature in the room that day, and you guys can just plug your numbers in and be able to go straight to the lab. So what we're trying to do here is all of our gas capturing devices, they're called eudiometers, have a maximum volume of 50 mils. So you want to make sure that you're generating some gas by reacting magnesium with hydrochloric acid to make magnesium chloride, and then the gas that you're collecting is hydrogen. So this is the guy that we're collecting, and this is our starting material. So what you need to be prepared to do is figure out what is the most mass of this that you can have and not produce so much gas that you completely empty out your eudiometer. So recall that the atmospheric pressure is going to be pushing down on the water, and you're going to be collecting gas, so hydrogen gas, so pressure of that. Also, since we're collecting it above water, there's going to be some water that evaporates, so we'll have a vapor pressure of water. So the pressure inside is equal to these two gases added together. So pressure outside equals pressure inside. What you're going to then need to be able to do is solve for your pressure of hydrogen, because you'll know this and you'll know this, and plug that into the ideal gas equation to figure out how many moles of magnesium you can use, you should notice that the stoichiometry here is 1 magnesium to 1 hydrogen. So when you solve for the moles of hydrogen, that also equals your moles of magnesium, and the volume that you'll be using is our maximum volume here, 50 milliliters. Then you'll just need to convert that mass to mass of magnesium. And that way you know what is the most magnesium that you can use, and not like ruin your experiment by creating so much gas volume that it completely empties this out. The next calculation that you'll have to do before you can actually carry out the lab is a stoichiometry Chinese menu. So let me make a new slide here and we do that. Mg plus 2HCl makes MgCl2 plus hydrogen gas. You're also going to need to figure out how much hydrochloric acid to use, and it is 10 molar, so think of that as 10 moles per liter. And you'll need to take your mass of magnesium and solve for volume of HCl, given that it is 10 moles per liter. And then we will be looking for a 15-fold excess. So if you go over your Chinese menu so that you can do mass of magnesium and look at the steps that you'll need to do so that you can get volume of HCl, your day on Thursday will go a whole lot smoother. So post any comments if you have any questions, and I'll see those and try and get back with you. Otherwise, enjoy your day.